Hello again. Let's go to our course page. Type my name, Hyoung-Goo Kang, at Google. Click the very first link, Hyoung-Goo Kang Google site. And then teaching, financial case research. Then you can reach our syllabus and then click the first hyperlink over here. Now let's move to our second topic. Okay. From mean variance optimization to multi-factor models, we present. Okay. Let's define some terminologies. Suppose there are n risk assets and whose rate of returns are given by the random variable R1, Rn. So they are returns. Then what is the return? Return is basically nominator is change of the asset price and denominator is most recent asset price. So this is return. And they are usually random variable. If we usually we know this one, but we don't know this one. In this case, it's random variable. So suppose we have n, capital N, number of assets, risk assets. So n is from 1 to n. We have n number of risk assets. Now let's form the portfolio. In order to form portfolio, we need a portfolio weight, and this W. This W is from weight for each one. We have n risk asset, therefore we need n weight with transpose here. Usually it's convenient to define vector as a column vector. So here W subscript n denotes the proportion of the wealth invested in asset n. Because it's a portfolio and the weight should be sum to 1. So the sum of this weight becomes 1, right? Now we have return of each asset and we have portfolio weight. Therefore, we can define portfolio return. Portfolio return RP. Portfolio return RP is simply weighted average of the return of each risk asset. Okay, so it's a return. Now variance. In order to define variance, we have to define mean first. The first, usually we call mean and variance as the first and second moment. So the first two moments of RP, again RP is, as though it is a portfolio return. For the first moment, which is expected value. So expected return your expected return of your portfolio. So you can regard this RP. Suppose you invest $1. If you invest $1 in the portfolio, tomorrow you will make your wealth will become 1 plus RP. If RP is positive, you make money. If RP is negative, it is less than 1, therefore you lose money, right? So 1 plus RP is your next day wealth. And if you put expectation over here, it is your expected return or expected net return. Okay. So expected net return is because expectation can go inside of summation, right? So simply expected return of your portfolio is weighted average of expected return of individual asset, right? Here mu n is simply expected value of individual asset. Now variance. Variance is the, usually we write the sigma p square, your portfolio variance. Usually we want this one high, we want this one low. We are happy this is high because we can make more money. We happy if it is low because we are usually risk averse. So we want safety, right? So we prefer this as 4. But anyway, the variance is that this is simply notation of variance of portfolio P, and this is simply this one, right? Covariance of this one and this one. So for example, let's start 그림판 MS Paint. MS Paint. Variance of x plus y. In high school, we learn how to do that, right? This is simply variance x plus variance y plus covariance of xy, right? Actually, variance of x, this is simply covariance between x and x. This is the covariance between y and y, right? Covariance with itself is simply variance, right? And then we have now constant a square variance x, right? Now variance ax by is simply a square covariance with itself, right? Which is simply variance plus 2ab of covariance of xy and b square covariance of y, right? And what? We missed that. So this is instead of a square, it is a. This is b multiplied by b. Okay, so that's why we have wi, wj like this one. And then if we denote covariance Ri, Rj as simply sigma ij, right? Then this one is compactly this one. And actually, if we use matrix, we can simplify notation for this one. We have two summation, which is not so pretty. We can simplify this one further. Okay, this one, let us use omega as a called covariance matrix. Very important concept in finance. Covariance matrix. Covariance matrix is everything in finance. Almost everything in finance. In risk management and asset price, almost everything in asset price. This covariance matrix, let's use omega covariance, which I explain shortly. Then sigma p square is omega transpose, no, w transpose omega w. Here w is portfolio weight. Then what is variance covariance matrix? Simply let's take a look at this one. Okay, let's take a look at this one. Okay, let's take a look at this one. So if we write down this one, let me use this thicker one. So basically I, J, Wi, Wj, sigma I, J, right? I ignore 1 to n. Let me write down 1 to n, okay? And this one is basically now w1, wn, and then we have a big matrix, and then w1, wn, right? Oh, sorry, it should be capital N, right? Capital N, right? This one, and then this one is 1, 1, 2 2 1 sorry 1 2 1 2 1 and this is 2 1 and 1 and then this is n, right? This one should be n minus 1 n, right? And you can easily check that they are same. Yeah, they are same. And we can compactly write that this one is a transpose of W matrix, transpose, and in this entire thing we write down this omega, so omega, and this is W again, right? So this one becomes simplified to this one, right? And this here, if you look at this matrix, the each element is covariance between ith asset, ith return, and then jth return. Suppose we have I, j, it is ith return, covariance between ith return and jth return, right? Covariance between I and j. This is I, this is j. So this is covariance between ij. All these elements are covariant. That's why we call this covariance matrix. So if we use this covariance matrix, we can simplify analysis a lot, right? We can save a lot of notation. In the next page, we have more explanation about the covariance matrix. Okay. Suppose we have a column vector to the x1, xn, and we can define covariance as sigma ij is a covariance xi, xj, and of course covariance is the expectation of xi minus expectation of xi, and yj minus expectation of yj, where mu I is expectation of xi. So we can conceptually think of a big matrix, sigma, in which the element is I covariant between ith variable and jth variable, right? And this is called covariance matrix. Usually, if we put this one inverse over, of course, if it exists, it is inverse, called inverse covariance matrix. Sometimes in finance, we call concentration matrix or precision matrix. This inverse is sometimes called precision matrix. Okay. The next period. Now, let's consider only two asset portfolio. Now consider two risk assets. Suppose we have two assets like IBM and Google, or Samsung Electronics and LG Electronics. Suppose we have two risk assets, and we know the expected value, mean, and variance. Usually we have to also estimate mean and variance, but for make matters simple, let's assume we know means, expected value, and we know variance. Suppose we know that. And then now, suppose we have alpha, 1 minus alpha and alpha with the weight of asset 1, asset 2. Because the weight should be sum to 1, and we have only 2 assets. If we denote allocation to one asset as alpha, and the other one should be 1 minus alpha, then alpha plus 1 minus alpha should be because of 1, right? Now, portfolio mean is, of course, weighted average or the mean of the each asset. So R bar P, which is portfolio mean, is 1 minus alpha R1 bar plus alpha R2 bar. Here, we have assumption that alpha is between 0 and 1, but it is not necessary. When alpha is less than 0, it is possible that alpha is less than 0. When alpha is less than 0, well, we hold negative amount of asset 2, which means that we are shorting. We short asset 2, and then we invest more in R1. On the other hand, when alpha is greater than 1, then allocation to asset 1 is less than 1, and allocation to asset 2 is more than 100%, which means we short sell asset 1 and invest the proceed from the short sale and invest in asset 2. Okay. Now portfolio variance. Sigma p square looks like this. Now we have a new notation for rho. Rho is simply correlation, right? Correlation. So, as you know, you know, this is the covariance, right? This is the covariance between S1 and S2, and we know covariance is simply correlation in the standard deviation of S1 and S2. So here, usually correlation between two assets, correlation between the two assets is defined. Actually, it's definition. Definition is actually 1, 2, and it divided with standard deviation of each asset. Right? It is a definition of correlation. So if we use this one, then we have this notation. Right? This notation. Now we have portfolio mean and portfolio variance, right? And then this R1, R2, rho, sigma 1, sigma 2, they are all known value. And as we change alpha, as we change portfolio weight, this one will change and this one will change. Because our question is how they change. That's our usual interest. So here in this 2S problem, our objective is to change alpha such that we construct portfolio that we like. Okay. Usually we like portfolio with big portfolio mean but small portfolio variance, right? So our goal is to choose alpha such that we choose desired combination of this one and this one. Now, in the next slide, it shows combination. Okay, so let's go to this one again. This one again, and then again let's assume two asset cases, and then let's think about the y-axis and then x-axis, and then it is usually customary that this one x is sigma of the portfolio standard deviation, right? Not variance, portfolio standard deviation. So it is standard deviation, so we have to put square root over here, right? We have to put square root over here, entire square root. And then this is portfolio mean, right? And then in this example, we have two assets. First asset is somewhere here. With this sigma and this expected return. Second asset is somewhere here, right? Now, as if this is, of course, when alpha is 1, right? This happens, actually alpha is 0, because when alpha is 0, this is the case when alpha is 0, and this is the case when alpha is 1. Remember, when alpha is 1, we hold only second asset. When alpha is 0, we hold only first asset. So this exact point is performance of portfolio when alpha is 0 and alpha is 1. Now our question is, what would be the profile of standard deviation and return when we change alpha? We will cover that topic in the next class.